So I am Jeremy Dudman-Jones. I'm from Greenford High School. This is my 30th year of teaching. And I was in this very room probably about 30 years ago. I did a geography PGCE. And I've moved around just a little bit. At the moment I'm doing government politics. But I have to say, one of my genuine interests is psychology. I am very envious of you all because I do now really, really like psychology. And I'm also interested in neuroscience. So about 6-7 years ago, I came across lovely Caroline, who sat at the back there. And she invited me to come along to join this organisation, Learnus. Please write it down if there's anything you get away from today, take away from today. Learnus is hopefully going to be it. And Learnus is an opportunity to try and engage teachers with academics. So the research that the academics are doing at UCL, Oxford, Cambridge, Bristol, lots of different parts of the United Kingdom and the rest of the world. And it's an opportunity to get teachers to talk to the academics and the academics to talk to teachers. So it's a wonderful organisation. And I go around doing presentations to student teachers like yourselves, my own students I talk to, and I go to schools as well. Right, so it all was inspired actually by comments made by people like you. I wanted to talk to people when I taught here. I was a similar position to Min. I used to come in and talk about politics and stuff to student teachers. And I used to want to talk to them at the end about what was going on in the brain. And I remember one of them saying, yeah, but I really don't care what goes on under the bonnet as long as I can drive the car. And that was the thing that I think inspired me to say, well, I think as teachers, we communicate with the brain all the time. You guys understand that more than anybody else because you understand the brain a bit more. And I think as teachers, we should understand just a little bit more about what goes on in the brain. And also with learners, I think as teachers, we should really find out what the academics are doing so that maybe it can enhance stroke sort of help what we are doing as practitioners. Right, so just a little test. You're all going to be really good at this because you're all psychologists, so you understand these things. Okay, some of you are sociologists, so you might not understand this, but sociologists, you understand everything anyway. We only use 10% of our brain. Hands up, you think that's true? Hands up, you think that's true? You're not, are you confidently not putting your hand up, or? Yeah, you know it's not true. That's coffee from a straw. That is good. That's impressive. I like that. So 10% of our brain. No, we don't. We use 100%. There was a film, wasn't there? It's called Lucy, I think, where apparently she got better and better and better and better and then took over the universe. You're not going to be able to do that. You do use 100% of your brain. So we need to get rid of those sorts of myths. Left or right-sided person. Are you a left or right-sided person? Hands up if you think that's true. Oh, only one person. No, you were. Pressure from the peers there. You were going to put your hand out and then you took it down. You're right. The rest of you are right. Sorry. Well done for not putting your hand up. You all work together. Both sides do work together. There is some evidence that men are sort of better at the sort of staying in the same hemisphere. Women seem to be much better at doing the bilateral hemispheric thing, getting across and communicating with both hemispheres. I doubt whether or not, or I should imagine it's not because of biology. I should imagine because of the environment that women seem to be better at communicating between the two, which suggests an answer to the next one. Men and women's brains work differently. Hands up if you think that's true. Some of you saying true, confidently saying no. There are some, I have just said it, yeah, there are some morphological differences and there are some behavioural differences as well, but probably learnt behaviour as opposed to anything that is deterministic. Critical periods when we should be taught certain things, it's very popular at the moment, isn't it, these critical periods, is that true? Very good, yeah. Well, actually, they call them sensitive periods now, but I think you're right in the sense that there are certain sensitive periods. Classic experiment over, I think, up to the age of 3 years old. If you don't expose somebody to a sound before the age of 3 years old, then they're never going to be able to acquire that sound, which is quite interesting. I think it's sort of Japanese. If somebody from Japan comes across to London, they don't say the L, they say Rundon. And no matter how much you try and teach them the L sound, they can't pick up the L sound. It's always going to be Rundon, for example. And then we'll move on. We will move on because we haven't got an awful lot of time. So this is you guys, the Institute of Education. Learnus, I think, is trying to establish something about the toothbrush theory. The toothbrush theory is this idea that we all have a toothbrush, but none of us want to share our toothbrush. So we're trying to tackle that, I think. For me, that's the big issue. So we've got all of these ideas are out there, but sometimes people don't want to share them. And what we want to do in Learnus is to try and share those ideas. Right, you're all going to tell me who this particular person was, I should imagine. Do you know Phineas? Yes. All of you? Sociologists are saying no. See, you missed out on a whole lot. Do you want to explain or shall I? I'll explain, don't worry. So we have this chap, 1858. I'm going to go with you. 1858, you sort of suggested that you knew as well. About 1858, United States of America, east coast of the United States of America, and his expertise was in explosives. And so he worked for the railroad company, and he would take away, I suppose, the geomorphology. He would take away the geology that was getting in the way of the railroads, i.e. he'd make a straight line for the railroads. And the only way to do that was to dynamite things. And so he would drill holes, and then he'd put the dynamite down, and he'd take a tapering iron, and he would carefully, with a wooden mallet, he would knock the tapering iron to compress the dynamite. Then he'd put the charge in, then he'd go a long way away and he'd explode it, off it would go, and then they could clear it away and they'd lay the track. On this one occasion, he picked up what he thought was the wooden mallet. It wasn't a wooden mallet, it was a metal one, metal on metal, spark, down the thing, dynamite dish, tapering iron, up into head. Not a nice picture, not a nice image. So up into head, went through here, out through here, lay on the floor, totally dead. Oh, yeah, she knows the end of the story. Very good. Not dead at all. Shook his head, zombie-esque, which is a bit weird, given you've got a tapering iron sticking out of it. And the people that came running over, knowing that he was dead, said to him, is everything okay? And he understood everything they were saying. They thought, well, that's a bit unusual. What's your name? He knew his name, President of the United States of America, etc., etc. He knew everything. Took him to the doctors. The doctors sort of asked him some questions. Who are you married to? What age? Who are your sons, daughters? Blah, blah, blah. Excuse me, blah, 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 said all of those things, responded correctly, and so they just took the tapering iron out, stitched here, everything was fine, no worries. 10 years later, he died in San Francisco, a broken person. He couldn't stick to any particular job. He was rude. He didn't have any concept of social norms. If he thought somebody was ugly, he'd walk up and tell them. If he thought somebody was rude, he'd walk up and tell them. If somebody said they want to fight, he'd have a fight regardless. He drank heavily. He was divorced from his wife, and his children didn't want to see him again. Terrible, sad. Why? Well, they assumed it was because it went through that frontal part of his brain. And so for me, this was the beginning. When I first read about this back in the 1990s, I did think, well, that's quite exciting. This is the start of an understanding of just how important different parts of the brain are. It had actually gone through the frontal lobe. The frontal lobe is the bit, as you know, that deals with central executive function. It allows us to make decisions. It now allows us to make, in inverted commas, rational decisions. HM, I think you know about. He used to be HM. Do we know about HM? Sociologists, you know about HM. No, don't pick on me. No, I don't. So Henry was a nice guy, good-looking chap, I think. Story goes, 13 years old, new bike for Christmas, fell off the new bike for Christmas, hit his head, epilepsy, not very nice. Anyone that's had epileptic fits, or as a teacher you might have seen, or as a student you might have seen, not very pleasant. Lasts for about a minute, 30 seconds. His would go on for about 5 minutes, not pleasant at all. He then fell in love. By the time he was sort of 24, he fell in love. Ah, lovely. And they wanted to get married, but he said, I don't want to marry you, I can't marry you. Horrible, horrible, because I'm going to have all these terrible epileptic fits. So in 1958, when he was around, a very brave or stupid consultant, surgeon said, don't worry, I will test you and I'll find out where it is in your brain that the epilepsy starts, and I'll remove that part and everything will be fine after that. So they did. This is his brain, actually, and they took the bit out from underneath here. It's the hippocampus, and they took it out through here. It's right in the centre of the brain, the limbic system, right in the centre of the brain. They realised that that was the bit that was stimulating the epileptic fits, so they removed it. And he woke up, and he had no more epileptic fits, no more. When he got to 50, though, he divorced his wife. Well, his wife divorced him because she was sick and tired of being kicked out of bed in the evening. So she would climb into bed, and he would say, "What are you doing in my bed?" And she would say, "I'm your wife." And he would say, "No, you're not my wife. This is my wife." And there would be a photograph, an image of the person that he married at 24. Because, of course, the hippocampus, as you all know, or maybe not, deals with taking the short-term memory and putting it into long-term memory. So this chap had no long-term memory after the operation. So after the age of 24, no long-term memory developed. So the person that was climbing into bed with him was not recognisable as the person that he married, and therefore he didn't recognise her. She was slightly older, greyer hair, wrinkles. I'm describing myself now, but that sort of thing. So psychologists now know where the sort of seat, I suppose, of memory actually is. And surely as teachers we have to accept that that is going to be a vital part of what we do as professionals. We should be interested in that sort of thing, that sort of knowledge. Great, have you learned something? Oh yes, so far so good. So Henry couldn't imagine future events either. So there is something really sort of intrinsically important about this weird thing called the hippocampus. Right, briefly going to play a good game now. Sir, are you okay?
Yeah.
Are you sure?
Yeah.
Yellow. That's yellow. It doesn't look yellow, but yellow. What is it? What part of the brain?
Frontal lobe?
You are good. Sociology or psychology?
Psychology.
Well done, sir. And what does it deal with?
Like I said, decision making with the prefrontal cortex is, yeah.
Very good. Central executive function, all that sort of stuff. Motor thinking, planning, you were going to say all of that?
Yeah.
Reasoning, risk taking. Very good. Right, let's pick on somebody over this side. Yes, young lady. How about green? That's supposed to be green. Temporal. We're going. Oh no, I'm not going to tell you just in case. But no, not the temporal at the moment. Any help? People with their head down, trying to pretend they're not in the class. Yes. Nice hat, by the way.
Is it Harry? Harry, I can't say it.
Very good. Yeah. You were going to say parietal.
Yeah.
Yeah, you were going to say parietal. Do you know what the parietal lobe is for?
Mine's gone blank.
Mine's gone blank. Anyone help? Parietal lobe. Well, yes.
For language processing.
A little bit of language processing. Some language processing a little bit low down. Mostly sort of stomatosensory stuff. So those of you that play piano, who plays piano? Surely somebody plays piano. A class of talented people, thank you very much. Used to. Lots and lots and lots of neurons devoted in that particular part to sense, to touching, that sort of stuff. So stomatosensory area. But importantly, parietal, very good. Okay, let's go down. This is supposed to be pink stroke purple. I saw the yawn. You're going to have to tell me now, just to get you involved. You have, it was said. She knows, well done. Not allowed to do that in a class, you can't, it's like a test. Temporal. And temporal important or not important? Bloody important, yeah, go on, yeah, it's really important. As teachers, really important. Why is it really important?
Language.
And?
Sound.
And? Shana, come on Shoshana. Memory. And?
Emotions.
Emotions, very good. This little bit here, I don't know if you could see it, that little bit here that apparently looks a bit like a shrimp. That's the hippocampus. That was the bit that Henry HM had taken out. It's the temporal lobe, all part of that L system, that limbic system, the emotional system. And the emotional system, important for us because it's clear that there's a relationship between the emotional system and memory. And as teachers, that's something that we really need to tap into because we want students to remember certain things. Not everything, but certain things. And then lastly, a little bit weird that it's at the back, but nonetheless, it is there and it's at the back. The last one, gentlemen. We've only got two gentlemen. How weird. And you were the first in. Round of applause being the first in. Well done, sir.
Is it I can't say it. It's with vision anyway.
It is the vision. Occipital. The occipital lobe. The occipital lobe. Here it is. Very good. And it's for vision. For me, a bit weird because it's right at the very back of the brain. It's here in the brain, even though the information's coming in here. It was put at the back of the brain, which is very strange. Right. Easy to do. Sir. Yellow.
Frontal lobe.
Very good. Tell me the information about it.
Oh, decision making. Yeah, that was the main one, I guess.
Okay. Central executive function.
Yeah, that's the one, yeah.
Planning, risk taking.
Good.
It's quite important, the planning and risk-taking, and important for you guys. I presume most of you are A-level GCSE teachers. No, nobody's being made to do classes low down the school. They haven't given you one of those hard-to-put-together citizenship classes or anything, have they, with Year 7s? You wait, that's coming. That is coming. You've got one, have you?
For Year 7 geography.
Oh, well done. Best subject, geography. Obviously psychology, but then geography. Yeah, so that is indeed the frontal lobe. Should we make her do it? Parietal. Oh, come on. Parietal. Parietal. Parietal? Parietal. Good. And parietal was to do with, sorry,
Language.
stomatosensory, touchy things, and the integration. Visual stomatosensory information. Okay, where do we go? Yes, young lady. Don't say anything.
Temporal.
Temporal. To do with
Language.
and emotions and memory. Very good. Very good. Oh, that was so good it didn't come up. Yes, it is. Here we go. And then lastly, you can say it now.
Occipital.
Occipital. Very good. The occipital lobe to do with vision. Brilliant. Actually, for me, that was a bit more of a sort of, I suppose, a training exercise, I suppose, in that sense. It's really unfair to break the brain up into these huge, great, distinct lobes, because it sort of suggests that that's the only part that can deal with some of those things. Clearly, they're all very, very, very closely integrated. They're joined together clearly, and obviously this is just one side. This happens to be the left-hand side of the brain, and you've got another hemisphere on the other side. I love this. Just as a little one, I get the students to do this. Is sort of break things up. So you must have done this in psychology. Have you done this in psychology? You must have done. Oh, okay. Okay. Oh, you're sociology as well. Well done. So stare at the nose. Stare at the nose. Stare at the dot on the nose. Stare at the white dot on the nose. Just keep staring at the white dot on the nose. Stare, stare, stare. You're not staring. What are you doing? Oh, you got to stare. Come on. Sorry to touch, but anyway, stare. Are you staring now? She's staring. She's staring. I've got the stare. You can't stare because I'm in the way. Apologies. Are you ready? Are you ready? Are you staring? Jump across the white. Oh. Do you like that? Did you see it? A little bit. Maybe sit there and then you can stare. Do you recognise her? Anyone of a particular age recognise her? Monica Lewinsky. Anyone remember Monica Lewinsky? Love that one. Got nothing to do particularly with education or neuroscience, but it's quite nice from a psychology point of view. See, sociology, you don't have any of these funny things, do you? Oh, is it not? Stare at the nose. Stare at the nose. Stare. Stare. Okay, go across the white. Can you see? Okay, this is good. This is good. See, as a teacher, you've now learned. Student teacher, when you do this, it's going to be better. Very good. I like it. Did anyone see this? How can you hate this? This is large. This is wonderful. Obviously, unruly class. I have to whistle. What an unruly class. It's fantastic. Ladies at the back, calm down. Or I'll move you to the front. This one, definitely white and gold. Everybody else is wrong. You're all wrong. Hands up, white and gold. Thank you. Hands up those people that can't see properly and think it's blue and black. So wrong. So wrong. Who sees it as white and gold? Shh. Stand up. How much do you... Stand up a second. How much do you know that is white and gold? Like, would you give me 10 quid? Could I give you 10 quid to just... It's white and gold. Yeah. What would you bet? 200 quid? 300? You've got that in my bag. Okay. Whatever you do have, I will double it. So would you... 50, you'd bet that's 50, that's white. I'd put my house on it. I'm that confident. That is literally... Thank you very much. Thank you. But you're all wrong. That's the colour. I love it when you just do that. See. That's the dress, though. So Thank you. There's an equally good one with flip-flops. I don't know if you've seen the one with flip-flops. There's a white and gold, blue and black concept with flip-flops. For me, this one, this is really interesting. I mean, it is about perception. I'm sure there's a lot of stuff that you guys do when it comes to perception. It's a good way of introducing perception, I would say. I like the other one as well for vision, but this one in terms of perception, I absolutely know that that is white and gold. I've never seen it as anything other than white and gold, and can get into quite a strong argument over the fact, but this is the actual dress. That dress is that. So actually, if you're a physicist and you wanted to measure the reflection and you wanted to measure the sort of radiated wavelengths, this would come out as blue and this would come out as black, even though I can't see that. Why? Well, it's because your brain changes a little bit, doesn't it? As you well know, your brain changes and it adapts to certain things. So for some reason, my brain has adapted to not really be bothered with the black and blue. I don't know why. Maybe I just see things as gold. Midas, something like that. Right, MRI stuff, very important. There's a couple obviously around the corner at UCL. Well, you're in UCL now, aren't you? But at UCL, the fMRI images are probably something that you guys are reasonably familiar with in psychology, not so much in sociology, but you've probably seen them. Anyone been in one of these contraptions? Noisy? Intimidating, claustrophobic, but it does mean that you can look inside. You can actually look inside the brain, the organs of the body, and I suppose from a brain point of view, you can sort of see what you think is happening in the brain when you ask people to behave in a particular way. So if you ask people to think of something that is funny and witty, then you can look and see which parts of the brain seem to be lit up more than other parts of the brain. The reason maybe that we get this 10% thing might have come from these sorts of images. This is sort of suggesting only a little bit of the brain is being used, but actually that's not the case. This just indicates that the computer has decided which bit of the brain is being used more than the rest of the brain. So it's getting rid of all of the sort of fuzzy stuff saying, well, not much activity is going on outside. Most of the blood is getting to, most of the oxygen is happening around here. That means that those are the cells that seem to be being used for this particular function. Does anyone know what this side is? You all sort of said it. It's a sort of language bit, the memory language reading bit. So this is a normal inverted commas student. This is a student that seems to have dyslexia, and this is the part of the brain that if you separate these two out, that's the bit that doesn't seem to be functioning in the same way for a dyslexic student. Very good. Neuromyths, we won't really dwell on too many of them. Brain gym, probably not something that you guys talk about particularly. I suppose from my point of view, beware of anyone that says, I've got a silver bullet that can tell you, well, it'll give you the answers to all sorts of problems and issues that we might have in education. So these were all things that came into education, and it was this genuine belief that if you did some of these things, then everything would be okay. That's not the case. So be a bit wary about neuromyths. Anyone that comes in and promises you the earth, you're not going to believe them, are you? No way. Yeah, sorry.
I was going to say, I remember when I was in primary school, they made us stop the lesson.
Yeah.
Thing where they had to follow the thumb. Is that what?
Yeah, that was brain gym. And see, there's a slight issue with brain gym. It's totally nonsense because it was sort of suggesting that by doing these sorts of exaggerated movements, you could connect one side of the brain to the other side. Well, they are connected. That's sort of what happens. But there was some evidence that this activity seemed to work. So they did have some data that suggested it worked. Well, it worked because if I got you all now, and all of you are a little bit tired, a little bit bored, to stand up, and I made you all stand on one leg and put one leg out there and do this, you would actually be energized. You'd get a little bit more, a bit of a kick. So is it a worthwhile thing to do? Well, yeah, I would say so. Should you call it brain gym? Well, not really, but yes, you can call it exercise. Do you do it in your lessons? Do you have any double periods? And do they get a little bit tired towards the end?
Depends.
Says in a pointing way, depends. Could you halfway through just break the whole thing up and say, right, I want everybody to stand up, put the leg out and do this, touch the ear that way and touch the ear that way and just see what happens? You're looking flabbergasted, aren't you? Are you going to try it?
Yeah.
Oh, you good. What it will do, it will certainly wake them up. Whether or not it actually allows them to do anything other than just take a breather and wake up, well, actually, that's not a bad thing. So I would agree that we shouldn't necessarily call it brain gym, but there seems to be some evidence that making people active halfway through the lesson or partway through the lesson works. Right. Socrates said this. You all deal with teenagers, don't you? So we're now going to focus on adolescents and teenagers. Socrates said this, what was this, 2,500 years ago? About 2,500 years ago. So in a lesson, I would ask somebody to read it out, but do you want to read it out? As Socrates would say, with a good Greek accent?
Oh, no, I don't know about that.
Okay. Irish accent?
No.
Australian?
Our youth now love luxury. They have bad manners, contemptible authority. They show disrespect for their elders and love chatter in place of exercise. They no longer rise when elders enter the room. They contradict their parents, chatter before company, gobble up their food, and tyrannize their teachers.
So that was 2,500 years ago. Somebody was saying that about adolescents, about teenagers. This is the bit that I get. That's they no longer rise when elders enter the room. This is terrible. None of you rose, did you? And I stood here, none of you rose. And they tyrannise their teachers. Look, they're tyrannising their teachers then. Shakespeare also talked about it in Winter's Tale. Nothing between getting wenches with child, wronging the ancient trade, stealing, fighting, blah, 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 blah. So even Shakespeare, back in sort of 1600, 1599, he was saying the same sort of thing about teenagers. And Hermann Hesse said the same thing about 150 years ago. As far as teachers are concerned, they define young geniuses as those who are bad, disrespectful, they smoke at 14, fall in love at 15. How dare they fall in love at 15? Well, can be found at 16 hanging out in bars, reading forbidden books, for goodness sake, writing scandalous essays, and occasionally they stare down their teacher in class. Turn your gaze. Terrible. So we're going to talk now really about adolescence, if that's okay. Is that okay? Good. Brain maturation, synaptic pruning, plasticity, circadian rhythms, and neurotransmitters or drugs. When I said everyone was addicted to drugs, some of you shook your head and sort of went, how dare he? But we are. We love drugs because we need them, and we need them because they are the chemicals. They're the chemicals that allow our brains to function. And increasingly, sadly, I suspect, amongst teachers, you're going to find smart drugs, you're going to find cognitive enhancers, probably the universities that you've come from, probably people in those universities have talked about these things. It will be an issue for you. Reward, you were very complimentary of this brilliant lesson that you gave, and one of the things you were all applauding her over, sorry, I didn't know your name, Kate, was that Kate was complimenting people and you were nice about it. So we like that reward thing. So let's look increasingly at the reward thing. So we're going to spend a little while, if that's okay, just talking about these three things. Most of the research that I'm going to be using actually is Dr. Jay Geed from sort of 2012-ish and on. He did this longitudinal study where he looked at brain scans of adolescents. Right, are we okay with the structure of these things in our brains? We're sort of okay with those. Sociologists are thinking going back to biology, but so first of all, numbers. Let's do a dog. Let's sort of find out exactly how many the dog has. These things are neurons, so these are the cells that are in the brain. So what do you reckon with a dog? How many of these do you think a dog has? These neurony things. You were away there for a second, weren't you?
No, I don't know how many.
Come on. Like 2 million, like 200,000, 55, 22, millions, 10 million, 10 million. You're confident with 10 million? No, you're not confident, just 10 million. Don't care. Never really been an issue for me. 5,000. This is a dog. I'm going to ask you, sir. I vaguely think you know. 4 billion in a dog. Okay, in a dog there are 500 million. There are about 500 million. An octopus has the same as a dog. Octopus are clever. They have about the same as a dog. So we've got about 500 million, okay? So you're a human, you've got more or less, it's a bit of a Bruce Forsyth, higher or lower, but I should imagine higher, very good. We have more than a dog, very good. Anyone want to hazard a guess? You sort of said a dog, 4 billion, so you're going to go with?
100 billion.
You're going to go with 100 billion. That's a lot, that's 100,000 million.
10 billion?
10 billion, you're going to go with 10 billion. And yeah, I haven't picked on you yet.
I don't know. 20 million?
20 million.
I don't know.
Oh, it's got to be a bit higher because 500 million. But anyway, don't worry. You're very close, sir. Yeah, I think it was a doctor in Argentina actually that did the centrifugal thing on someone's brain. Somebody offered their brain up, and she counted 86 billion. 86 billion. I know, it's really hard. Very, very, very interesting when you think about it. You have 86 billion of these things. So that's a lot of these nerve cells. That's a lot of these nerve cells. The fascinating thing from my point of view, and the thing that I think, as I say, if anything you're going to take away Learnus and this other idea, is that these nerve cells, they have dendrites coming in here, or leaving here, but they also have the axon terminal, and then they have the axon, then they have the axon terminals coming out at the end there. And those things are the things that connect with the next neuron, and the next neuron, and the next neuron, and the next neuron, and the next neuron. So this one connects with the dendrites of another nerve cell, and so on, and so on, and so on, and so on, and so on. And for a second, you're just going to try and imagine 86 billion of those things. So next time somebody says, don't drink any alcohol, you'll kill some neurons, you're going to say, who cares? I've got lots to kill. Don't worry. Also, you are going to be trying to imagine this, and then I'm going to say that each cell has between 5 and somebody said 35, but I can't imagine that, so I'm going to say 15, but 5 and 15,000 of these. So there aren't any mathematicians amongst you, but if you try and visualize what that means there's 86 billion of these. Each of them has 5 to 15,000 possible connections. Bloody amazing, aren't we, humans? And our brain is flipping amazing. And students have this flipping amazing brain as well. And the flipping amazing thing about this flipping amazing brain is that it can do an awful lot of wonderful things. An awful lot of wonderful things. Right, the other thing to remember is that at that point there where this cell tries to join the dendrite of another cell, they don't actually physically connect. You know that, I'm sure. They have that thing called a synapse, and that synapse is a gap, and that's why you like drugs. You like drugs because you need the chemical to be stimulated to move the information from one to another. So these are electrical impulses, and then there's a chemical impulse. Electrical impulse, then a chemical. Electrical, then chemical. So you've got the two together. So next time your parents say drugs are bad for you, you can say, shut up. You like them as well. This is myelin, and this myelin here is a sheath, and rather like, I suppose, a copper wire. You cover the copper wire with plastic to make it more efficient. We, humans, we have this myelin sheath, and that myelin sheath makes things much more efficient, i.e. the electrons, the electrical communication can get down here much, much, much faster. There's a nice little segue here, omega-3. You've probably heard of omega-3. It's quite a complex fat, the myelin, and it's difficult to get hold of it actually. But one of the fundamental fats is omega-3. So I suppose the next time your parents say you should eat fish, you absolutely should eat fish. Why? Because it contains loads of omega-3. So back in the day when people were eating cod liver oil or taking cod liver oil, actually they were getting quite a lot of this. Some of my students that just eat KFC, I don't think they're getting quite so much of this. And those that don't eat any greens, I would worry they don't get very much of it at all. Anything else that I wanted to talk about? Just briefly, John Stein was the person that made, well, one of the people that made this link between omega-3 and the myelin. And his brother is a very famous fish chef called Rick Stein. Do you know Rick Stein? I like that. Family connection. So he goes round and round and round. John Stein and Rick Stein. And lastly, when people talk about grey matter and white matter, they're talking about this bit. And white matter, they're talking about this bit, because myelin is white. Myelin is white, or it comes across as appearing to be white. Any questions? Don't feel afraid. Ask some questions. Come on. One question? How many? 86?
Billion.
Very good. White matter is?
The myelin.
Very good, very good, very good. Okay, I like this photo. I show it to students. It's one of the nicest photos, but one of the saddest photos as well. You probably have seen this photo before. Anyone seen the photo before? Okay, so this is a newborn child's brain. Inspiring but sad. Sad because obviously the child is was born dead, and the parents very kindly allowed it to a slice to be taken from the brain. These are the neurons. So this is the cell and this is the neuron. So you can see that bit, the cell body, is the dark bit, this is a week-old child. This is a 6-week-old child. And this is a 6-month-old child. So the neurons stay the same. What's happening for you and for me, I suppose, is learning is happening. And the learning is the connectivity. And that's what you're interested in. When you came into the lesson today, and I probably will call it a lesson, you didn't know about 86 billion. You might not have been able to pronounce parietal. You probably knew, visualized, but couldn't say occipital. If you can now say occipital, and 86 billion neurons, you know that, and you know parietal. The amazing thing is what's happened to your brain. It's made some connections. Literally today, whilst you've been sat here thinking nothing's happening, actually you've made a new little connection. You've made a new axon terminal. Oh man, that's exciting. I get tingles down my back when I think about it. And as a teacher, that's what your aim is. Every single lesson, that's what you want to do. Does the brain want to do it? Sort of on the whole, it wants to do it. More frequently, it probably just wants to think about how it's going to get home and what's going to happen at the weekend and whether or not Arsenal are going to lose again. Arsenal fan, bunch of power, anyway. So for me, it's a really inspiring thing, really, really inspiring, wonderfully inspiring. I will show you briefly, just in case you've never seen. I think it's probably here. Okay, have you ever seen this? So this is an axon cone. So it is supposed to, its job is, this is from a very, very, very young neuron. And this is another axon. And what you should see is this sort of growing out. It's time-lapse photography. But if you've never seen axons growing, there you go, you can see. So when you remembered 86 billion, that's sort of what your brain has done. It's eureka moment, it's made the connection. Oh, another one's made the connection. Oh, another one coming up here is made the, oh, another one coming out here. Oh, another one coming out here made the connection. So I often show this to students, and the students are absolutely flabbergasted by the idea that the thing that they thought was just sort of set is actually incredibly fluid and very, very, very flexible. In neuroscience and psychology, you guys don't call it fluid and flexible. You use the word I'm going to refer to you because I'm sure you know. It begins with P. Plasticity, yeah, it's that wonderful thing called plasticity. And I suppose the last thing, after Learnus and the other things that I've told you to remember, the other thing that you need to remember is this idea of plasticity. It's a wonderful concept, plasticity. It means that the brain can adapt and change and mold and do what it needs to do. It is changeable. It is plastic. Right, but for you guys have got teenagers. Most of you are dealing with teenagers. This is again from Jay Geed, and what he was measuring now is the amount of grey matter and the amount of white matter. So basically, what happens is that from being a 5-year-old to being a 20-year-old, you don't have less grey matter, but you have an increase. There seems to be an increase in white matter. There's a slight decrease in grey matter because not quite so many dendrites and axon terminals, but you have a significant increase in white matter. It means that you get very efficient at sending information down those particular axons. That means you get very good at doing the things that you really like. It's really, really impressive. You get very good at making these quick decisions. You like sociology, you get very good at doing sociology. You like psychology, you get very good at doing psychology. You get very good at, I don't know, what you get very good at? Sociology, you get very good. I thought you were going to say something like dance. No, okay. You're very good at doing those things. And that's what your students are doing. They are in this particular period. They are going through this change. And every teenager does it. Every adolescent does it. they decide sort of subconsciously what they enjoy, and as they enjoy it, they get better and better and better and better and better at it. The sad thing from my point of view is that we try and encourage them to get very, very, very good, specialised in certain things, almost too quickly for me, and that means the brain then decides that it doesn't need the other stuff. So what does it do to the other stuff? It prunes it away, it cuts it away. So this is at birth, this is the 6-year-old, this is the 14-year-old. What do you notice between the 6-year-old and the 14-year-old? They have more connections, weirdly, much more complicated brains, much more interesting, I suppose, from the sense that they can make really circuitous decisions from one point to another point. They go down these sort of almost B roads to get to make a decision. Sometimes 6-year-olds can't even make the decision because they get so lost in all of this sort of process. Whereas teenagers and us, we're really good at making decisions. We're very good at making decisions. We have like motorways connecting our decision making from A to B. But maybe we lose some of that sort of creativity. And I suppose the sad thing from my point of view is the pruning. It's a natural thing, and it happens all the time. It happens every time you go to sleep. You don't really remember what you were wearing the day before, I don't think. Do you remember what you were wearing yesterday? Yeah, you do? What about 2 days ago? 3 days ago. You are exceptional. What were you wearing 4 days ago? Exactly. So you don't really need to remember those things. So at sleep, you are pruning away some of that information because you don't need all of that information. And you're retaining the information that your brain feels that it does need. So this idea that neurons that fire together, they wire together, they stay connected. If you don't use them, then the brain quite sensibly is going to cut them away, get rid of them. You're going to remember 86 billion today. I don't know if you'll remember it in 2 weeks' time. Probably will, actually, because it's an easy number to remember. Parietal, maybe you'll forget how to say parietal, maybe occipital. You've got it today, but how long will it stay for? And as teachers, that's fundamental to what you are doing. You need to know that this information is going to be retained. It's not going to be pruned away. But you're also dealing with the emotional side of teenagers. From an emotional side, that bit of the brain, this temporal bit, I don't know if you noticed, that bit developed really early on. That bit matured really early on. They have a very strong emotional sort of capacity, really strong emotional capacity. They sense emotions really, really, really sensitively. They're really sensitive to those things, like an adult. And yet their risk-taking part, this part that you were talking about, the frontal lobe, not developed. So you've got the emotional stuff that is of an adult, and you've got the risk-taking stuff that is not of an adult. So I like to think of my own children. They like skiing, and they stand on the top of a black run, and they're looking down going, whoa, and they can sense the emotion that they're going to get from all of this. But they're not really at the age of 13, 14, 15. I didn't think they were able to assess the risk, because going down there looked bloody dangerous to me. So they stood on the top and went off, and I stood on the top and went, nah, it's too risky. Down the blue run, much nicer, much safer, thank you very much. But you're dealing with those students that are almost programmed to be making some of these risky behaviours, quite rightly so, but making some of these risky choices. It does go on a little bit earlier than puberty, and it happens on a regular basis, on hopefully a nightly basis for those of you that do get some sleep. Right. Plasticity, as you quite rightly pointed out, I'm very concerned about time, actually. Apologies. Right, so I'm going to get you to think, just for a second or so, because we don't have an awful lot. Is there anything that I've said so far that you might be able to use in terms of your teaching? So if you don't mind chatting to each other amongst yourselves, as Kate quite rightly said, not much time, so only a minute or so. What is it that you might or might not do in terms of your teaching, knowing specifically about the whole plasticity thing, the plasticity thing? Definitely encourage them to play more sport, that's what I would say. But anyway, go for it. Very good, yeah. We talked back here, I didn't mention it to you, but you might have picked up on it. It's sort of the spiral curriculum, so you develop a curriculum where you return to things that are really important. Touch upon them in year 7, not that you get a chance to in year 7, because you're doing the psychology stuff, but keep going to them, keep returning to them. Very good. My own view, I suppose, for what it's worth, is your psychologists. I mean, that's so exciting, because to understand psychology, you do need to understand a bit of sociology. You probably need to understand quite a lot of biology. You probably need to understand a lot of stuff about behavior. The idea that your students then say, well, we're just psychologists, I think you should challenge, and you should say, well, to be a good psychologist, don't lose your interest in data and maths. Don't lose your interest in chemistry. Don't lose your interest in biology. And actually you overtly spend time reminding them that actually they should maintain this interest in stuff. They should go to the Royal Institution lectures, where they do a lot of talks on psychology, or the Gresham College lectures, because they should keep their minds open. And if you keep your minds open on a literal and metaphorical way, actually you aren't going to synaptically prune anything, because you're keeping it all ticking over. As long as you're doing these things, keep it ticking over. Any of your talented psychologists, you must get to know your students. I'm sure you do. It's a brilliant way of engaging with them. If they do play the piano and they've given up, then you're the ones that say, you shouldn't give up the piano. Keep the piano going, because the more you practice, the better you're going to get. And it's really exciting, really interesting, and your brain can keep up, etc., etc. And if you did used to dance, then you should continue to do your dancing as well. You really should. And in sociology, you can't understand sociology without an insight into, weirdly, people's behaviour. So you must have an insight into a bit of psychology, a lot of politics, I suspect, a lot of history, I suspect, a lot of philosophy, I suspect, and a reminder about all of those things, bringing all of those things back into the lesson again, means that they don't walk out in a sort of blinkered way and think, well, I'm just a sociologist. They don't. They sort of go, I'm a person of the world. And to understand sociology, I really do need to be, I don't know, a polymath, don't you? You really do need to understand a lot of what's going on. You need literature, you need art, you need all sorts of things to understand that. That's something that I would want you to emphasise, want you to strengthen. Right, circadian rhythms. Are we okay with circadian rhythms? Especially the dancers. Don't know why I'm picking on you as a dancer. Have you ever danced? Damn, anybody else dance I can pick on? Okay, right, so do you two mind standing up and moving here? Do you two mind standing up and moving here? Hey, what were you wearing yesterday? You so don't remember. Do you two mind standing up and moving here? And do you two mind standing up and moving here? And do you two mind standing up and moving over there? Don't take your stuff, because you're going to be going back to those people. Friendship groups you'll return to, and you can trust no one's going to nick any mobile phones, are they? Okay, take your mobile phones, just in case. Go there. Yeah. Say hello to your new friends. Quick introduction. You're going to stay standing, that's fine. Or you're going to do the rhythm. You're going to do the dance. Are we okay with circadian rhythms? Maybe, maybe not. Circadian rhythms. Russell Foster, I think he's doing, Caroline, is he? I think he is doing some research into it still. Really, really interesting guy. Does anyone do TED Talks? Oh, I love a good TED Talk. So if you don't love a good TED Talk, you should. They're only 20 minutes long. Russell Foster does a very good one. So have a look at his TED Talks. And it is about adolescent sleep patterns. Anyone got children? Do your children sleep?
They do now.
How old are they?
6 and 8.
Oh, they're not going to.
8 and 2.
Oh, you're lucky. You're at the stage where they're still sleep.
2 and 5.
Okay, they sleep. You wait until you get teenagers. Woo, they're very funny. Anyway, so Russell Foster did a lot of work on circadian rhythm. I think he won a Nobel Prize actually on the work that he did. They discovered that there was a new cell in the back of the eye that was light sensitive but didn't connect to the occipital lobe. It connected to the sort of sleep areas. So even blind people were sensitive to this circadian rhythm, this day-night rhythm, So at daytime we tend to be awake, and at nighttime we tend to try and fall asleep. Right, does anyone have that in their lessons? Have you ever had that in your lesson? Have you ever had that?
No.
No? Is that because you walk up and wake up? Have you ever had that one? Never had that one? Someone's admitting it. Has that happened to anyone in one of Miss Dziecięcki? Is she Min? Any one of Min sessions? Any of you sit at the back and just have a little doze? No? Kate? Anyone fall asleep during Kate's session this morning?
Oh, no.
Never, Kate, never. Well done. So my interesting, slight interesting anecdote, I suppose, for this one is the 15-year-old that took the Italian government to court. I like that. Department for Education to court. And he took them to court and he was suing them. And he was suing them for quite a significant amount of money, in the millions of euros, because he'd been to one of these sorts of talks where he'd read about Russell Foster's work. So what Russell Foster realised, or others, not just Russell Foster, realised that we need this stuff called melatonin, which is another drug we like, you know, a hormone-y thing, a chemical that we like, and it tells us that we're sleepy. And when I get home from work at around about 9:30, I start to nest, I start to settle down on the sofa, and I cover myself with cushions and settle down in front of some sort of mindless TV program or a good book or whatever it is. And by about 10:30, I'm ready, seriously ready to sleep. And I go to sleep at about 10:30. And that's normal for 8-year-olds and 2-year-olds and 5-year-olds and 20 and adults over the age of sort of 21, 22, 23. But the sad age is not a sad age at all, but the exciting age of the 13 to 22-year-old means that they don't start producing this melatonin for some reason until an hour later. So whereas you're getting tired at 9:30, they're not getting tired until 10:30. Whereas you want to go to sleep at 10:30, 11, they don't want to go to sleep until 12, 12:30. Which means that when you want to wake up, because you've had your night's sleep and everything's okay, you want to wake up at, some of you, 6:30 or 7. They don't want to. They don't want to wake up until 7:30, 8:30, 9 even. 12, yeah, they don't want to. And it literally seems to be a biological thing. I don't know what the evolutionary advantage of this particular thing was or is, but there seems to be this thing, and this is what happens to the adolescent. So why was the 15-year-old trying to sue the Italian government? Torture. In Italy, they have to wake up and get to school, which starts sometimes 7:30 in some of those Mediterranean countries. Yeah, it was all right them finishing at 1. Not if you're a teenager. You don't want to. You want to be asleep until 1. You definitely don't want to be. And he said the Italian government know about this, and therefore they've been torturing him for the best part of 10 years. Therefore, he needs compensation for 7 years worth of torture, knowing torture, premeditated, planned torture, that is institutional, and therefore, well, the Italian Department of Education said, no, we're not going to pay you, get out. But I quite liked it, you know, as a little anecdote. It's quite a nice, succinct way of putting it. Okay, what happens at night time then? The neurons aren't the most abundant cells. You've got these things called glial cells in there as well. And the glial cells are attached, these things here, they're attached to the neurons. And because they're attached to the neurons, they sort of hang around. At night time, they are the ones that decide what is to be pruned and what isn't. Obviously, they do this chemically, but they are the ones that decide which of those connections are no longer necessary, no longer needed, i.e. what you were wearing yesterday, or how you got into school 2 weeks ago. You're not going to remember any of those things. There does seem to be, and I'm sure a couple of psychologists will correct me, but there does seem to be a condition where some people claim that they remember everything. I don't know if you've ever read about these people, these savants that have this ability seemingly to memorise or remember anything. I couldn't think of anything worse than somebody sort of going, what were you wearing on the 25th of November 1992? And if I could remember it, it would do my head in. That would just be awful. But they seem to remember everything. But most of us functioning adults, we couldn't cope with all of that. And so the glial cells go around and they cut things away. They get rid of that stuff. Well, if you don't sleep, they're not able to do the things that are needed. And if your students don't sleep, they're also not able to cut away or prune away some of those unnecessary links. The other thing about the cells are, well, you all know, cells give off well, they use up a lot of energy, but they also give off lots of waste products, toxins. I suppose the analogy might be that if you run a lot, you eventually build up quite a lot of lactic acid, and that lactic acid makes your muscles cramp, and you've got to rest, and you've got to sit down, literally have to sit down and physically allow your body to recover. Gets rid of all of the build-up of the lactic acid. Well, the cells in your brain would be doing the same sort of thing, especially after a session like today where you're going to have to concentrate listening to me for 2 hours. Your brain is really, really working bloody hard, unless it's drifting off and falling asleep. But it is working incredibly hard, building up some of those, in inverted commas, toxins, those waste products. Well, at night time, that's really the only time that your body can do what the runner would do when they sit down and rest. And it's a really, really important thing to do, to get rid of some of those waste products, stroke toxins. You had a question?
I was just going to ask, if you have like a particularly bad memory, don't feel like you have a great memory, is that to do with the glial cells, or is that to do with like your hippocampus and how you go from short term to long term?
Really to do with drugs. I think maybe we'll touch upon that in a minute. I think it probably is. Students, your age group of students, I suspect most of you are dealing with year 12, some of you might be lucky enough to do year 11s, but you are dealing with that age group of student. And most of you, certainly for me, it's a big issue. It's a really big issue. A, what they eat, and B, the amount of sleep that they get. What stops them or prevents them from sleeping, other than the fact that somebody's had an argument with them? Yeah, well done. I completely agree with you. It's these things, isn't it? It's the mobile phones. And the other thing about what Russell Foster and the other people that work in this sort of area realise is that there are certain wavelengths that stimulate you. There are certain wavelengths that make you stay awake. And it's the blue light that makes you stay awake. So I don't know if you know, but these things, these tablets, they have a backlight that is a blue light, and that's a very sensible thing. If you're Apple, that's a very sensible thing to do. You want people to stay awake and to be stimulated and use these things all the time. If you've got a laptop, it's the same thing. And if you have a mobile phone, it's exactly the same thing. These smartphones produce the same thing. So your body is then tricked into thinking it isn't darkness, it isn't night time, therefore the melatonin is going to be suppressed, and therefore you're not going to want to sleep until even later. So it is definitely something for you to consider, I think, as teachers. Those mobile phones that are so important to you, and therefore they're going to be very important to the next generation, your students, you're going to have to figure out some way of making this disconnect. It's a very important disconnect. Some people do say that you can have a nighttime shift on it. It turns it from blue to red, yellow and red, which is sort of okay, but they're still being stimulated, aren't they? Somebody's being stimulated because they're reading the requests or looking at the number of likes or worrying that no one's put a smiley face on for the last 15 seconds. Or such and such hasn't connected with them or communicated with them. That sort of stimulation, as psychologists, you know that sort of stimulation is really very important. So in 41 states in the United States of America, they've got changes to the time of the school day with their high schools and their senior highs. UCL Academy, Hampton Court, Monk's Eaton was one of the first ones to do it. A large number of schools now are actually changing the timing of the school day depending on the age of the students, and I suppose when you go for your interviews, and you're all going to be going for interviews pretty soon, and maybe it's one of the things you're going to find out. Year 11s, 12s and 13s quite often in London schools now are going to start a little bit later. I say often, it's probably not often, but there are a number of schools now that are going to start a little bit later. My own view, I don't know. I think you made a valid point, but they then have to stay until a lot later. And you also have to remember the well-being of the teachers, because you are the adults and your melatonin is working, so your well-being is really very important as well, and you don't want to be in school until 6 o'clock marking. Because you're all there until 9 o'clock marking, and then you go home until 10 o'clock and you're still marking. This team.
You spoke about chunking activity.
Chunking. How's that help with sleep? It's not, you're the guest in this team, aren't you? It should be the
Just keeping them alert, like every 10 minutes, and then change an activity.
Okay.
Something new.
That's, very good. I quite like that as an idea. I don't know, about 10 minutes. Spaced learning suggests that it shouldn't be 10 minutes, it should be like 20-minute chunks. And then what do you do between those 20-minute chunks? Something completely different that's got nothing to do, like chuck a ball in the air or play with a piece of plasticine. Space learning, it's called. Have a quick look. And lastly, this team. Time in the school day again. Guys, thanks. Yeah, there is a, I suppose when you, because hopefully you're going to continue and become head teachers and senior leaders and all that sort of stuff. There is an issue, isn't there, about when you have your lessons. So if you constantly timetable your maths lessons to be the first lessons of the day for your year 11s and your year 10s, probably not very sensible. And if you constantly have your English language lessons last thing on a Friday, probably not very sensible. So those sorts of issues, I think those curriculum timetabling clashy issues are also something worth thinking about and something to consider. Very good. So 2 guests, can you move on? 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 Say your goodbyes, kissing on both cheeks. Off you go. Finally, we're going to talk about drugs. I've talked about drugs a couple of times. We're going to talk about neurotransmitters and briefly talk about reward systems. The 2 that I'm going to, they're not the most common. The most common are glutamate and GABA. They're the most common neurotransmitters. But 2 that I want to focus on a little bit are going to be dopamine and serotonin. It turns out there was a guy called Eric Cantona, because he's a footballer, so it's not him. Eric Cantor, that won his Nobel Prize. He was looking into serotonin and the connections. And he realised that to make these connections stick, so to make parietal stick, to make 86 billion stick, and to make occipital stick, what you as teachers needed to do is you needed to figure out a way of getting 5 squirts. So you need 5 squirts of this stuff. And this stuff is a motivational drug. It's a mood memory drug. It's very important. We like it. It rewards us. But from a teacher's point of view, it's fundamental it's the bit that sort of ensures that short-term stuff turns into long-term stuff, short-term into long-term. So hopefully you've got the impression, because hopefully in this lesson I've sort of attempted to model what it is that I wanted some of you to get out of it. I want you to get 86 billion, I want you to get occipital, and I want you to get parietal. I hopefully have returned to you guys enough times to slightly make you a bit embarrassed in that I point at you. And so you're there and you have this little stimulus. I don't know whether or not you felt it. Did you detect a certain ooh, ooh, ooh? And you might have detected a certain ooh, and you hopefully detected a certain ooh as well. That certain ooh every time I did it meant that your brain had no choice. It served you a little bit of serotonin that was connected to the thing that I wanted you to remember. And hopefully everybody else has sort of picked it up. What's the, how does she say the word? Oh, corrector. Hasn't worked at all. Forget her. Parietal. How many billion? 86, correct. What's this bit at the back? Occipital, very good. Is that correct? Yeah. Yes, very good, very good. So you need to figure out a way of getting these 5 squirts. And the genius of a good teacher is that you have the knowledge, you've got the content, but you've also hopefully got the artistry and the creativity to combine those 2 together and recognise what it is that you need to get across in that particular lesson. Those objectives that Kate quite rightly pointed out. Have you gone away and remembered what those objectives were? If not, then actually you failed a little bit, and what you need to do is to go back and go, okay, what were my fundamental, probably only 1 or 2 objectives that I fundamentally wanted somebody to leave with. And if that's the case, you need to figure out ways of giving them about 5 squirts of this stuff. Very good, so you're all contemplating that one. The other one that you really like is dopamine. Dopamine is such a good drug. So good. Aldous and Milner, they did this, I think, in the 1960s, psychologists in the 1960s, and they stimulated the dopamine receptors in the brain of a rat. And after 3 weeks, what happened to the rat? Died. Died with a bloody big grin on its face, though. Literally. Gave up drinking, gave up eating, gave up sex, didn't care, just sat there, just smiling, just loving life, just not moving because it didn't need to. Why didn't it need to? Because it was just being rewarded all of the time, and therefore it had no motivation to do anything else. So we know that this drug is a really, really important drug. Just how important it is in education, I think the jury is out. There's a guy called Paul Howard-Jones who's looking at reward systems. But we do know that from my point of view, it's the oh shit drug. And I call it the oh shit drug because I can remember a couple of vivid moments in my life. One of them was when I was 24 and I was looking in that direction, sorry, but looking at you. And I went, oh shit, when my wife walked in, my future wife, she wasn't my wife at the time, and I went, you are beautiful, wow. So for me, that was a dopamine moment. I can look in that direction and I can see it still. It's there in my mind's eye, so to speak. I can see that moment, that oh shit moment. My other oh shit moment is this direction, and it's this direction because you're on the phone, but anyway, is this direction. As I walked across the zebra crossing at 6 years old, my mum had sent me down to get some salad cream around about Christmas time. I even remember it was salad cream. I had to go down the road, and she did say, whatever you do, you walk across the zebra crossing, go across the zebra crossing, make sure you go across the zebra crossing. What she failed to tell me is you don't just walk across the zebra crossing, you have to stop before you go to the zebra crossing. And I started to walk across the zebra crossing, and my oh shit moment was, oh shit, as this juggernaut came towards me and stopped around about here. And I can vividly remember the guy as he climbed out of the cabin, and he used words that I'd never heard of before as a 6-year-old. I did have to go home and ask my mum what the W word was. Why am I a W word, mum? What is that word? Slightly awkward for my poor mum. But that was that moment as well, that really, really important moment. Do you get it in education? My word, rarely. Should you get it in education? I suppose occasionally. Occasionally you should for those really fundamentally important moments. Probably moments in psychology when you take them on a trip somewhere. Possibly if you take them, I don't know, to Auschwitz to see what human behaviour can actually ultimately be, or when you take them to see Zimbardo do his conferences. He does loads of conferences, doesn't he, about his Stanford University prisoner experiments, those sorts of things. Those for your students will be those dopamine moments, So the problem with dopamine, though, is that when you give it, it really, really works. It really works. It changes the brain's behaviour. It makes the brain reassess what the environment is like out there. It makes them. It's that moment when you're walking around and all of a sudden a lion jumps out at you, or your teacher slaps the table and you suddenly jump and you think, whoa, whoa. But then if I do the banging again, you sort of go, yeah, all right, he's going to bang the table. You still get a bit of it, but it's nowhere near the same. So that's the problem, I suppose, about this sort of dopamine drug. There's some interesting work going on about how to maximize dopamine. And the way to maximize dopamine is to be unpredictable. So Kate, one of my criticisms based on this is you're a bit too predictable with your thing. You went around sort of like, you're good, you're really good, really good. Maybe what you should have done is, what were you saying? Seriously? She's going to stop. She might be a bit offended, but she's going to stop. She is going to think, that was a terrible answer. Like, really terrible. How on earth could you possibly say that? Really? I'm not suggesting all of the time, but I am suggesting every now and again that you have something that is a little bit out of the norm, a little bit unpredictable. Because if it's just a case of, well done, you've done really good work again, then she's not going to get much of a reward from that. Not much at all. So some of the work that's been going on at the moment on dopamine that you might be interested in is randomizing the rewards. So you randomizing the rewards. You think, who's going to get it? So you don't randomize it, but they think it's randomized. Who's going to get it and how? So I think it's right in saying on camera that Paul Howard-Jones has done some work on this. He's a neuroscientist, education neuroscientist working down in Bristol. And he's done it specifically on that sort of thing. So, you know, when you do quizzes, he's looked at randomizing rewards for quizzes, making it really competitive and randomizing the reward for quizzes. The other one, Howard-Jones, Paul Howard-Jones. The other one that's really important is oxytocin. Any opportunity for me to get the beloved Arsenal up there, so I've got Arsenal up there. And oxytocin is one of those, it's that team building thing. We produce it, well, women produce it a lot straight after childbirth. Loads and loads and loads, which means that when you look at your baby, you sort of go, you are the most beautiful thing that has ever lived, even though it looks like Winston Churchill. But that's another story. And when somebody comes along and says, how beautiful is my baby? And they hesitate for a second. And they don't immediately say, that is a beautiful baby. You go, well, are you trying to criticize my baby? And you want to, I don't know, slap them or do whatever it is you want to do to them. So oxytocin is really quite important. And oxytocin is released when you have physical contact. Very good, you got a bit. And I got a bit. We're connected. Don't even know your name and we're connected. How cool is that? Yes, connected. So I wouldn't advocate doing what the Arsenal team do, which is once they score a goal, they jump on each other. If somebody gets the question right, don't just walk up and give them a kiss on both cheeks and say, yes, 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 yes. But there's an element of that. You know, when you meet them in the morning, I don't know whether or not you do spud them. Do you spud them or is that too passé? Do you spud? I spud. Not all the time, but you spud. Do you know a spud? Do you handshake? Do you high five? Do you... It's quite important. It's quite important. Sports psychologists, they understand this. They know that teamwork actually works when people are physically bonding with each other as well. Physically bonding with each other as well. So I'm not advocating that you go around and do what sometimes the PE teachers in my school, they literally pick the kids up sometimes, give hugs and then put them down again. I'm not suggesting that, but I am suggesting every now and again, you do a bit of a high five. You make it your group. Your group. This is my classroom with my group. You're part of my team. My team is quite an important team to us. And we do physically high-five each other. We do that. Oxytocin, really interesting way. It attracts people. It attracts people to other people. Right. I'm conscious of the time. We don't have an awful lot of time left. Incidentally, some nasty people have managed to put this in sprays. And apparently you can buy this stuff and you can go around discos and you can just like squirt it next to somebody you quite like. Just give it a little bit weird. It's a love drug. Wander up to somebody you quite like. You don't even have to then chat up line. Well, then you just fancy yourself. Just look at yourself in a narcissistic way. Okay, so I suppose you read so beautifully. Do you want to read again?
No, next one else.
Would you want to read somebody else? Would you mind?
No.
Go for it.
Your family of origin, your culture, your friends, your work, every movie, every conversation have left footprints in your nervous system. These indelible, microscopic impressions accumulate to make you who you are and constrain who you can become.
Very good. I do like that one. So finally, I think for this little section here, I worry a bit for your generation of teachers. Caroline and I have talked about this at one of the focus group meetings that we had this week, actually, wasn't it? Modafinil. I don't know if you've heard of modafinil. Has anyone heard of modafinil? You're lying. Modafinil is a cognitive enhancing drug. And as a cognitive enhancing drug, I think it's for narcolepsy. So those people that fall asleep, it keeps them stimulated and wakes them up. So some unsavory people out there have realized that actually this is quite good because it makes people concentrate. And if it makes people concentrate, then they can learn more. And if they can learn more, then they're going to get better grades. These two here, you've got modafinil here, but these two, nootropic drugs, these are cognitive enhancers. They are what you guys have as caffeine. Ladies, are you okay? Can we stay just for 5 more minutes? Those two drugs there, these cognitive enhancers, they mean that you are more focused on something. Ritalin is a common one for ADHD. It sort of calms people down, but it makes people concentrate. So they're out there, they are available, and I suspect that students of your generation are going to be increasingly worrying or having to worry about what drugs your students are taking. Not my generation when it was cannabis and alcohol. This is going to be, in inverted commas, smart drugs. So be aware. I don't know, find out a little bit about them maybe. I do know that modafinil seems to be out there on university campuses. How much is actually, I know someone that knows someone that knows someone that knows someone that knows someone. How much of it is that, or how much of it is actually students are starting to use it, I don't know. But it is going to be an area of interest, certainly for student teachers, I would say, in years to come. Yes?
Is that what Pro Plus is?
Well, Pro Plus is just lots and lots and lots of caffeine. So if you take, but it is a similar sort of thing. It's just not as good. These things are much, 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 much better at doing the keeping you stimulated. The problem is that if you are focused on something, it doesn't necessarily need to be your essay. It could be Facebook. So you sort of go, you take the modafinil and then you're on Facebook instead of your essay, and you get really good at doing Facebook. Oh my God! And you forget to do your essay. We won't do that, because you've only got 4 minutes. But in your lessons, what would you do? Well, do remember that serotonin. Please remember serotonin. Please remember the oh shit drug, the dopamine. Randomise those rewards just a little bit, maybe. And do remember the oxytocin. If you're not going to do a spud, then do an elbow. If you're not going to do an elbow, do a high five or just smile a bit. I don't know. But the physical contact is quite important. What about you guys then with your cognitive psychology? We haven't even touched upon cognitive psychology. It's really fascinating, really interesting, and it's stuff that you already know. So the reason I'm not particularly going to touch upon it now, and I do with the economics and business students, is that you already know about it. So go back to the stuff that you know. Working memory, you all know about working memory. Does anyone know about Daniel Kahneman with his... Has anyone read Daniel Kahneman's Thinking Fast and Slow? Oh, psychologists, you should all read Daniel Kahneman's Thinking Fast and Slow. He won a Nobel Prize, but they couldn't give him the Nobel Prize for psychology because there isn't a Nobel Prize for psychology. So they gave him one for economics, behavioural economics in particular. But his background is psychology. It's fascinating, an incredible book, a really, really interesting book. And any psychologist or sociologist should be reading them. But have you come across the halo effect, I think, in psychology? You know about the halo effect. Well, if you know about the halo effect, you should be using it, and you should be talking to other members of staff about it that don't know about it. You almost have a duty of care to those people. Innate causality, you know, things dropping to the ground at different times. Well, they don't drop to the ground at different times. You know, if you take a hammer and you take a small tennis ball, they will drop to the ground at the same time. But you won't innately. You'll be thinking, of course, that's not the case. That's just silly. Let's because you lot know about it, it's almost a case of, well, make certain you challenge these things. Cognitive load, priming and anchoring. I think you're quite good at priming and anchoring. You understand it. You certainly did. You probably did dissertations on it back at university. I sort of tried to prime, I think it was you, over numbers. Did I do the priming of numbers? I said, how many neurons are there in a dog's brain? And you literally went, I've no bloody idea. What do you do? So I primed you with a number. I said, I don't know, thousands? And somebody over here said, yeah, maybe 50,000, 50,000. You prime and you anchor things all of the time. I don't know, when you look around your classroom, how many sad faces are in there? Those sorts of things. How often is the language around your classroom language that's inspiring language? How much is in your classroom? Is there too much in your classroom? Does it lead to this cognitive load as you look around a classroom and a student looks and goes, geez, there's just so much going on here. This is a bit too bare, I have to say, in this classroom, but is yours just too full of stuff, too full of stuff? Loss aversion, confirmation bias. You all know about confirmation bias, and when you become managers and you surround yourself with people that believe the same thing as you believe, is that a good thing? Not necessarily. So use your wisdom, use your expertise in psychology, because you know these things. Regression to the mean. If you have students that are constantly surrounded by the same like-minded students, they're going to regress to some sort of mean of those students. Mix it up a bit, change things around. You have the power to do that. Yeah, we won't talk about that one. This is system number 1, okay? How long did it take you to figure that one out? This is system number 1. So what face has that girl got? Is she happy or sad? Is she happy or sad? It shouldn't take you more than a millisecond to figure it out. You're good. She's not at all happy, is she? Didn't take you long, did it? If I flash that up, it would take you not very long to figure it out. This is system number 2, which is what I've asked you to do today. So thank you very much. And what you are going to be asking your students to do constantly. And this requires effort. And you are asking your students to do this. So this is system 2. Should take less than a millisecond. Yeah, that's the response. It's an interesting response though, isn't it? Because that's sort of the response that your students are giving you sometimes. Oh my God, what do you really expect me to do that? Shut up. Because what they're going to do is to go to the default solution. And the default solution is do the thing that they find really easy, really easy. That's the system number one. That's this. We find this really easy. Oh, let's have a little gossip. Oh, let's sit in the corner. I'm sorry to pick on you, but let's have a little gossip in the corner and talk about something that's got nothing to do with this sort of stuff. Really hard, because you're asking people to work at this. Work. And remember, if you're making those connections require proteins, they require energy. That stuff is expensive for the body to produce, and it'll only do it if it really feels it needs to, or it's getting the motivation from somewhere. Do you remember these? I still look at that, and I still say the top one is longer. I know it's not longer, but every time that's system number one where I go, no, that is longer. That is shorter, but it isn't, is it? Obviously it isn't. And the bat and the ball one, very easy solution. How much does the ball cost? 10 cents. Yeah, 10 cents? Some of you are looking, not even thinking, are you? You're just looking. If I look, then he won't pick on me. System number one would say 10 cents, and that's the easy solution. Obviously, it isn't. When you think about it, it's got to be 5 cents. It's got to be 5 cents. It's got to be 5 cents. I know you're all going to go, what is he talking about? Right, that is my reading list, and you've done very well. I've finished. Min's come in. Thank you very much for listening. Take a photo of the reading list should you wish to, and join Learnus, please. Take care. Thank you.